right auricle is here. Left auricle should have been here, so my fingertips are where the auricles would be. The anterior of the heart is facing forward out there. Okay. And the diagonal vessel is the pulmonary trunk. Even with the sheep heart, this works. You find those two auricles first. You don't really have to care which is right or left, but at least you know which is the top of the heart, because that's where the auricles are. And as you put the auricles right to left, or turn it around right left, you'll see on one side only this diagonal trunk. And that's the pulmonary trunk, and that's the anterior side of the heart. That should help you with finding that. On the model of the heart, you don't have to cut away and get anything, and nothing is deflated. Everything is nice and inflated, like all the vessels are always that way. Not true. These two vessels are the superior vena cava and the inferior vena cava. Joining them on the posterior side of the heart, this blue vessel coming across, coming in, this is the coronary sinus. That's the name we're using. Now, I know sometimes you'll see it as coronary sulcus, and I wouldn't mark you wrong, but this part of the test will be multiple choice, and it's going to be coronary sulcus. Now, this coronary sulcus comes around, the superior and inferior vena cava come together, and they're all going to bring deoxygenated blood back to the right atrium. The right atrium of the heart can be seen by taking this piece off. And it really doesn't matter if you leave the piece off. It'll fall off eventually anyway. But try to keep all the pieces together. I just sort of put them down here like a, what do they call it? No, a Chinese restaurant where they have all the appetizers on one plate. Yeah, that's it. You're going to need a flame though. Okay. In here, it shows in black where the entrance from the inferior vena cava is, okay, and the superior vena cava is. And also in black, what's that supposed to represent? The entrance in from what? Coronary sinus. And we also call that opening then the coronary sinus. So those three black spots in here are the three entrances for returning blood to the right atrium. The auricle of the right atrium is still partially present up here. Now the blood has to exit through the right atrium, and this you do from memory the first time usually, and it's going to go to the right ventricle. The valve that goes through is the tricuspid valve. It has three parts. So there are three parts here, sort of an aluminum color. See, those are the cusps of the valve. It's quite large compared to everything else. And then we go ahead and take off this part. And this is the right ventricle. These are the cusps of which valve? The tricuspid valve. The little cords, which they're representing here almost in triangles, in groups, what are those cords?
Cording tendon.
And they attach to small, in this case small muscles, here, here, and here. Those muscles are all papillary muscles. Now, I think in reality the papillary muscles are bigger than this model wants to show, and they certainly were in the sheep heart. Okay, you saw some really nice papillary muscles there. The tenderized portion, indented portion, what's that called?
Trabeculae.
Trabeculae carneae. Right. Okay. From this chamber of the heart, the blood is still deoxygenated. It's coming down here because this is the chamber along with the left ventricle. This right ventricle is going to contract forcefully and push the blood considerable distance. It's only having to push it, though, to the lungs, and those are pretty close by. So it doesn't have to be as big as that final chamber, the left one, that's pushing it throughout the body. But when it pushes, it's going to push, it can't push back up against the tricuspid valve. No, it will. It'll just shut it. It can't go back through unless the valve is leaking. Okay, that's what I mean by leaky valve. But it has to go up this way and out through this pulmonary trunk. Now, I'll put the pulmonary trunk back in place. And of course, the question is, what stops blood from coming back into the right ventricle? The pulmonary semilunar valve. So where is it in the model?
Between the right ventricle and the pulmonary trunk.
Pulmonary trunk is where it should be, but you don't see it because you haven't looked at that side of the model. There it is. They're showing it here. And they've got all three cusps sort of inflated so that they can't let anything through. That's a pretty neat way of showing it, I think. You know, it's so that would fit back right into here.